Before we go on to molecules that have two chiral carbons, it would be good to go through and make sure we understand the words that are associated with this section of organic chemistry. The first word is chirality or chiral. Anything that has no plane of symmetry has a handedness to it, whether they're molecules or a pair of scissors. Something that has no plane of symmetry is said to be chiral or has a handedness. Now, when we look at molecules, a chiral molecule will have a non-superimposable mirror image. Those two molecules, the non-superimposable mirror images, are called enantiomers. So these two molecules, R2-bromobutane and S2-bromobutane, are said to be enantiomers. The next definition is what I call a chiral carbon, or some books call it a stereocenter. It's any carbon that has 4 different things attached to it. That would be said to be a stereocenter or a chiral carbon. Obviously, if it has 4 different things attached, it must be an sp3 carbon. We're going to skip diastereomers because you need to have 2 chiral carbons to have a diastereomer. So we'll skip that and move on to what it means to be optically active. Any molecule that is chiral is said to be optically active. Now, this red box sort of diagrams what happens to light as it passes through a polarizing filter. So unpolarized light has all sorts of different directions to go. When it goes through the polarizing filter, it always goes in one direction. Now, if we take this plain polarized light and shine it through 2 different compounds, one R and one S, then this plain polarized light will bend a certain amount when it goes to the R enantiomer, and the same amount, only the different direction, when it goes to the S enantiomer. So using plain polarized light is a way to test for optical activity, and in order to be optically active, a compound must be chiral. Again, we're going to skip this meso compound definition until we get to 2 chiral carbons, because you need to have 2 chiral carbons to be a meso compound. But let's look at racemic mixture. A racemic mixture is a 50-50 mixture of enantiomers. So if I take 50% R2-bromobutane and 50% S2-bromobutane, I would have a racemic mixture. Now, each one of the enantiomers in the mixture is optically active. But once we mix the 2 together, the light will not bend at all, because 50% of the time it will move this direction and 50% of the time it will move this direction, and the light will pass through a racemic mixture without bending.